Because NASA has said there is an invisible monster on the loose. And not just any old monster, it's a runaway black hole that has got a mass of about 20 million suns. So it's a biggie. It's a biggie. Let's talk to space and planetary scientist Andy Lound, who joins us now. Andy, good to see you. Look, I know we shouldn't panic. We've nothing to panic about with this as yet, but it sounds worrying, doesn't it?
It's great. It's a great thing, isn't it? Happy Easter to you both. Yes, what we've got here is something which is actually quite fantastic. We have a giant black hole, which is not at the centre of a galaxy where most of them are. It's actually racing through the universe. And I think that's brilliant. What you've actually got here is discovered by total accident. Is you've got the collision of two galaxies that's taken place, and in the centre of the galaxies you've obviously got a black hole. But one of those galaxies had two black holes, which suggests it'd already been a merger. And what happened is during this collision of the galaxies, the one black hole was thrown clear, and therefore it's racing through space. The other two black holes, of course, with the laws of physics, had to move in the opposite direction. So that's quite exciting as well, something to look for. But this now is racing through space, and as it races through space, its massive mass has this huge amount of gravity in it. And space isn't empty, it's full of gas and dust. And as it pushes through space, it starts to interact and heat up the gas and dust in front of it, which, of course, due to the gravity, is bent and pulled around it, and therefore has a trail of gas, which then cools, and that cooling gas now forms stars. So it's actually creating stars, and by definition, it must therefore be creating planets going around them as well as it tears through space. If you like, it's like a speedboat going over a lake and ploughing through the algae. And as the algae separates and it pulls behind it in its wake, well, that's what it's doing with the dust and gas. So as it races through space, it's actually creating new worlds. And this is what's got everybody so excited, because we're now seeing a new way where worlds can be actually created, stars and planets. And of course, it's traveling. I think if it was, its speed is so great that it would only take it 14 minutes to get from the Earth to the Moon, for instance. It's just a phenomenal speed for a huge, massive object.
Where is it, Andy?
Oh, it's a long way away. I mean, the incident happened about something like 500 million years ago. So it's an awful long way away from us. We don't have to worry about it. It's millions of light years away. The big thing was it was actually discovered by accident. NASA were looking at globular clusters, and they actually saw a streak, which they didn't know what that was. So they decided to have a close look at the streak and found it was the birth of new stars. And at the end of it, of course, you can't see anything. And then they actually were able to calculate, well, oh, wait a minute, it's going to take 20 million solar masses to actually create this effect. And therefore, it's a black hole.
Wow.
What I find, sorry to bleat on, but you know I love all of this stuff, Andy. What fascinates me is something, because it's obviously big, and black holes warp space-time around them, which is mind-blowing. But what effect does that have then on all that space it's passing through and anything it comes anywhere close to?
Oh, this is it. It actually starts warping space as it moves through. As I say, it's like the boat going over a lake, really, and distorting. If you take the water in a lake as being space-time and you have a speedboat going through it, you see the ripples and contortions caused by it. This is what actually is happening with this black hole itself. What's interesting, because it's not static, it's tearing through space itself. It's having massive effects on the dust and gas around it. And, of course, if it comes close to another system, it will have a big effect on that. In some cases, it could be a detrimental effect on that. But it's not, as it races through space, sucking stuff in because it's traveling too fast. It's, if you like, pushing everything away from it and around it. So it's not, because it's going too fast, it can't suck the stuff in. The stuff is being deflected before it ever gets close enough to it because of its gravitational field. And that's what makes it interesting. I mean, there's got to be more than one of these flying around the universe, which gives you an indication of another way of things can be formed. Now, let's take this trail of stars which is trailing behind it. These, of course, trailing way behind it will eventually themselves possibly form a new galaxy in its own right. I mean, the trail is about 200,000 light years long, which isn't far off the diameter the size of a decent galaxy, which suggests this could be a way a galaxy actually could be formed. Something I don't think we've actually thought of before.
Well, that is so exciting, isn't it? And really fascinating as well. Andy, what's the no, it generally is, but I need the basics here. So what is the lifespan of a black hole? I mean, you've already said that it's already become double its size. Is it just going to keep growing and keep moving faster and faster?
Well, the speed of it will keep going. This one goes. I mean, you've got to ask a great question for how old black holes can get, and we simply don't know. There is a theoretical mathematical limit for the size a black hole can get, although that has actually been breached twice in observations made in the last few months, which is interesting. In theory, you could keep feeding it, but there has to be something to give at some point because of the material that happens around it, because all that material can't constantly exist. Eventually, it feeds to such a point where the material gets blasted away from it, because you have what's called the accretion disk around it, which is an area where stuff can't fall in and it can't quite fall out, and it gets stuck. And that has a tendency to emit huge amounts of energy, which can blast dust and gas away from it, and therefore it stops feeding, but just sits there as a dense, massive area of gravity and just sits there in space. So we don't think they sort of disappear at all. They sort of just remain. And there's some suggestions of whether or not the universe in the end will be a series of black holes scattered around or not. We simply don't know. But one other interesting idea is that this universe and all universes, multiple universes, are formed from black holes in our universe. So our universe creates a black hole. That material eventually gets pulled in and eventually comes out as a white hole, creating a new universe somewhere else. So they could be actually the precursors to other universes. But again, that's still in the realms of science fiction and theory more than anything else.
But that's the thing, isn't it, Andy? We just don't know. I mean, we know that they're full of matter. I mean, they're depicted in that graphic. It's almost depicted as just like a black sun, if you like. But we actually don't, with that amount of gravity and material and all the rest of it, we just don't know what happens to it.
We have no idea. I mean, we need to get into it, and you can't, of course. I mean, it just breaks everything back down to the fundamental particles that form this universe to start with, which is going back to square one, and it's quite phenomenal. The thing is the mass of it. This huge, massive thing. Light itself cannot escape. It's that massive, and that is just the figures. I mean, we're talking figures to the powers, because they're just too big, because you can't actually conceive the actual numbers of how big these things are. In the scale of massive, I mean, physical diameter, it's probably relatively quite small. That's what surprises everybody. But it's all compressed into this small area, which is what's quite dramatic.